All right, hey, it's Mr. Kaczynski. We're going to simplify radical expressions using the distributive property today. Things get a little tricky here, so hang with me till the end. All right, so this one's just basic distributive property. Negative 2 times 3 is negative 3 times the square root of 2. That expression can't be simplified. And then negative 2, or negative square root of 2 times positive square root of 3 is negative square root of 6. We'll just do 2 times 3 is 6. And that can't be simplified either. So that actually is our answer. All right, square root of 5 times 10. I'm going to distribute here. That's 10 square root of 5. That can't be simplified. And then here it's you're best served with a little mental math. Square root of 5 times square root of 5 is square root of 25, or just 5. So 10 times the square root of 5 minus 5. And there's nothing we can do with that. Remember to add or subtract. You've got to have the same square root sign attached. Okay, now things get a little tricky because now we're going to need to simplify even more than we did in the last one. Square root of 55 times 4 is 4 times the square root of 55. And then square root of 55 times 11, I think I'd look at that one like this. Square root of 55 is 5 times 11. And then we've also got the square root of 11. So 55, 5 times 11, times 11. And the reason I did that is so I could simplify easier. If you can recognize perfect squares, it makes things a lot more simple here. 11 times 11 is 121, and the square root of 121 is 11. So there's what our answer is going to look like. 4 times the square root of 55 minus 11 times the square root of 5. Other ways we could have shown our work, but we'll ultimately get to that answer. Now we get into multiplying binomials. It is still distributive property because we're going to distribute the 4 through this second binomial. 4 times 9 is 36, and 4 times the square root of 5, or 4 times negative 4 times the square root of 5 is negative 16 square root of 5. Now we'll distribute the square root of 7 through that second binomial. Square root of 7 times 9 is 9 times the square root of 7. And square root of 7 times negative 4 times the square root of 5 is negative 4 times the square root of 35. 7 times 5 is 35, since they're both in the square root sign. That actually, there's no like terms there that can be combined because they all have different radicals with them. Not going to be the case on this one. Same strategy though. Distribute the 8. All right, so 8 times 7 is 56. 8 times the square root of 11 is 8 times the square root of 11. Now we'll distribute this negative 6 times the square root of 11. Negative 6 times the square root of 11 times 7 is negative 42 times the square root of 11. And negative 6 times the square root of 11 times the square root of 11, that's like negative 6 times 11, which is negative 66. Now there's a few things we can combine here. We've got the 56 and the negative 66 is negative 10. We also have the 8 square root of 11 minus the 42 square root of 11, and 8 minus 42 is negative 34. So our answer here is negative 10 minus 34 times the square root of 11. One more, I wanted to show you one where we've got a binomial squared. Maybe you remember from when we had special products with quadratics. We had a rule that said a plus b squared is a squared plus 2ab plus b squared. You could do this one with the distributive property like we just did the last one, but I think this pattern's an easier one to go with. So a is 5 times the square root of 26 squared, and then we're going to do plus b 2 times a, which is 5 times the square root of 26, times c, or times b, I'm sorry, which is negative 9 times the square root of 91, plus b squared, which is negative 9 times the square root of 91 squared. All right, so a squared plus 2ab plus b squared. Okay. So this is going to be 5 squared, which is 25, times the square root of 26 squared, which is 26. On this next term, we're going to have 2 times negative 9 times 5. All right, so let's just show this here. 2 times 5 times negative 9, which is negative 90. And then square root of 26 times square root of 91, which I don't think, that's 2 times 13. Is 91 divisible by 13? It might be. Yeah, so we're going to write that like this. 2 times 13, that's 26, times 7 times 13, that's 91. And the reason I notice that is because the square root of 13 times 13 is 13. We'll get to that in a second. All right, and then this last term, we've got negative 9 squared, which is 81, and square root of 91 squared, which is 91. All right, 25 times 26 is 650. Then we've got our minus 90 times the square root of 169, or just 13. No reason I really need to bring 169 into it. And then my 2 times my 7 is 14. We're almost done, don't worry. 81 times 91 is 7,371. All right, so 650 plus 7,371 is 8,021. And then the negative 90 times the 13 is negative 1170 times the square root of 14. As ugly as it is, that's our answer. All right, you might need to watch that one another time to see what I did, but there's 6 examples of simplifying radical expressions using the distributive property. A lot of simplifying radicals in there too, which makes it a little bit difficult. Good luck. Let me know how it goes.